Hey everybody, today we're going to be having a quick little discussion on oscilloscopes and grafting meters. This is just an introduction. I'll be doing more how we can actually use the oscilloscope a little bit deeper on in another video. But let's get started here. All right. So what we're doing is we're just giving you an introduction to oscilloscopes. Now, they can be used for a lot of things. I tend to enjoy using oscilloscopes because they can give you more information. One of the things with oscilloscopes, they can give you voltage over time, where if you just take a DVOM out, then it will actually not give you as much information. And a lot of the DVMs are averaging too. So what we're going to really cover is kind of compare the different types of oscilloscopes that are out there. Fluke is one of the biggest type of manufacturers of oscilloscopes, but there was actually Tektronix and stuff like that actually do also have oscilloscopes. But I really feel that if you get yourself into using an oscilloscope, you'll tend to push away other meters and stuff like that too. But oscilloscopes, this is just one showing you a one type of one. There's other ones called analog oscilloscopes. One of the advantages of digital oscilloscopes is that you can actually record. Analogs do not have that capability. They were used early on. I still have my old analog when I was actually doing some messing around with electronics back in my early days like that. I actually went over to a digital scope, and they really help with the diagnostics of engine problems. And you can actually go doing engine problems and also other electrical problems. And I'll be showing that in a future video. So setting up an oscilloscope is fairly easy. Some of the oscilloscopes actually have their automatic settings. You don't have to do all this. You can actually program in what sensor. Picoscopes actually have that capability where you can actually scroll down and put different types of sensors, like you want to measure a oxygen sensor or a coolant sensor, and you can actually scroll down and it'll automatically set it up for you. But depending on the oscilloscope you have, you may have to set up certain certain types of settings, your voltage settings and your time settings. And one of the things I have on the screen right now is actually showing a 5-volt scale. So it actually will go up to 5 volts, and then it has a time setting of 100 milliseconds per division. Now, divisions are these little boxes you have here. These little boxes are considered divisions, and depending on how far, and we'll get deeper into the setup on that. Like I said, this is just an introduction to oscilloscopes, and digital meters. Sampling meters. So one of the things I didn't say early on is, what does DSO stand for? It said digital sampling oscilloscope. Okay, so it digitally samples, and then it writes it on the screen. So there's different types of other settings you can use. So depending on what kind of meter you get, you can induce some direct current coupling or DC coupling. This is kind of used on a lot of scopes because it allows you to see alternating current and direct current and when it's actually signals are present in a circuit. And then you have AC coupling can be used to actually show output signal waveforms for sensors. Like your distributor magnetic pickups. If you have an older vehicle that actually has a actual ignition module in it, and you can actually get your wheel speed sensors if they're AC, and your magnetic pickups if they're on your crank sensors, and your actually cam sensors too if they're AC, not a digital type. And we'll get into the different sensors as we go along too. So this helps you actually see that. And also on your alternators, and when your alternators they convert alternating current to direct current, you can actually have a leaking diode inside the alternator and actually show you some AC currents going on too. So it is very, very helpful on that. Whereas when you get into like your DVOMs or your DMMs, you end up having, guessing a lot of times. There are some tricks that you can do with that, and I'll be showing that in a later video also. So the other thing that great about oscilloscopes is you can actually see a digital pattern. Again, like I said, over voltage over time, and this really gets really some cool things you can do, and you can dissect it with a lot of the digital oscilloscopes where you couldn't do it with an analog, and I'll show you how to do that in a future video also. It's a lot of fun to do. So the oscilloscopes can show all the voltage signals, or you can actually show a shortish signal and see some of the peculiarities in some of this digital scopes too. You can show hertz, you can show duty cycles. Like I said, I'll be breaking all those down later on in a later video. And then your oscilloscopes will actually have, or your DSOs can actually have different channels, and this gets to be fun when you're comparing. I like to do this when I'm comparing oxygen sensor, different types of, see what each one of the oxygen sensor signals are looking like and comparing. And that's gets to be a lot of good, helpful information when you're diagnosing maybe like a lazy O2 sensor or oxygen sensor. You may want to compare RPM versus another sensor too. So we'll be getting into that too as we go along. But some scopes are 2-channel, 1-channel. Well, I should say 1-channel, 2-channel. I actually have played with 4 channels. If you get into more of your laptop types of DSOs, like your picoscopes, then you can actually have 4 different channels and set it up that way too, which gets to be where you can actually record it right to the laptop versus a handheld, which you maybe only have so much information stored into. So it gets to be a lot more, I would say that becomes a lot more valuable to a technician when he starts thinking about buying tools and stuff like that too. But remember, you have to have a laptop too. There are great things that you can do with the DSOs too. You can actually set trigger points to where it starts mapping or showing on the screen a pattern after a set point. So you just want to know, okay, I want to make sure, I want to see if it starts, when it starts going to, let's say, a volt. And so it goes up for that volt, and when it gets to that 1 volt, then it starts recording, or I should say, not so much recording, because there's our record functions too, which we'll be talking about later on in another video. But you can actually see a pattern start when it gets up to that 1 volt, and then it continues on, and which really gets to be, fun and actually give you a lot of information when you're actually diagnosing some of these sensors and some of the well, there again, you can actually have some of the DSOs actually measure not just voltage, but it's also amperage too. So that gets to be where it's really helpful information. So we have a trigger point, of course, when it actually closes, and then we have a trigger point when it actually starts going up like that. So I kind of got these two backwards, but you kind of get the idea. So the trigger point starts when it goes up, and this is when the trigger starts going down. So this is again, like I've been saying, but you can actually use a DSO to actually measure voltage even on a battery. So you want to see the battery, maybe you want to see when it starts charging and what the charging volt is, which some of your handheld DSOs will show you that where you have a regular digital voltmeter, that it'll actually do an average, and it'll just keep there an average of short. So you'll see it when it starts going down. But when you get into charging from an alternator, you'll start seeing that just kind of an average going in. So in between, okay, a voltage goes up to this, but in your alternator, you might see kind of a pattern where the alternator is not charging just straight, 14 volts. It may be going from 13.89 and going up a little bit, which is not bad, but you might see some kind of inconsistencies doing with a actual digital sampling oscilloscope. And some of your scan tools like this Vantage Pro actually has it built into their actual scan tool. And this is different than some of the scan tools, which we'll be talking about later on in another video, but it actually has it built into it. So you can actually flip it over to an oscilloscope versus having, a pattern inside of a data stream that you might have set up like for all the different kinds of PIDs. Okay, so that is different. You go in there and you see what the voltage is in your scan tool, and then it gives you a small little pattern. This one is a little bit easier to see when you go across like that. So just trying to give you an overview of it. It's kind of recapping all of it. On your right hand side, that is actually a Tektronix analog type meter, and you can see that it's only got one scale on it, or it's just one sensor input. Now again, this is only going to give you live type of information, whereas the one on the left actually is one of the different types. This is a handheld oscilloscope, and it may have several patterns or different ones that you can actually go through and see at the same time. So the analog, that's kind of you're left with just that particular one. Sure, you can buy an analog with different types of patterns and stuff like that, or different dissected and stacked for different types of measurements and stuff like that too. So you might have several different different types of information. And in there again, the analogs are beneficial for kind of live stuff going on, whereas your digital sampling oscilloscopes, they are sampling scopes. So you got to keep that in mind, and depending on the refresh rate, in other words, how much it updates itself, is how much of a lag time you might have too. So again, you get paid, you pay for what you get, and if you get something fairly inexpensive, you may not have something that will really work good for you too. All right, that's it for now. If you have any questions or any comments, please leave it down a comment down below. I would really appreciate if you like this video and also subscribe. And we will be putting more videos on oscilloscopes as the weeks go by. Take care now, and I'll talk to you soon. Bye for now.